Alright, so a while back I made a video about a piece of software I made just sort of as a proof of concept for myself that the software, the purpose of the software was to reproduce the first step of the human visual system in a computer. So the first step is basically like delineation of various edges in the visual scene, just finding those edges, and then it goes to do more with that, like finding the orientation and doing motion detection and that sort of thing. But I made the first layer of the visual processing system, and I showed it to you, and remember it was written in visualbasic.net, and it was sort of slow and that sort of thing. And I also mentioned how I was wanting to sort of port that to OpenCL, which is a standard which is backed by Apple and a bunch of others. It's a standard for concurrent programming. So where OpenGL is a standard for graphics programming, OpenCL is a standard for concurrent programming. So I mentioned about how I wanted to do that, and that was quite a long time ago. This semester in ComS 336, I found out that our research project is really like open-ended, and our instructor just wanted us to do something cool with graphics, and I was like, well, hey, maybe I can try out my try porting that program over now. And I asked him about it, and he said that was cool. So I basically got to do research that I was like interested in personally for school, which is awesome. So I'm going to kind of show you a comparison of like kind of like where I was at and what kind of the result of the research, I guess. So up here is the original code. It's in visualbasic.net 4, I guess. Lots of object-oriented doohickeys and that sort of thing. And remember, it was really slow, and we can run it again, and it's still going to be just as slow. You can open that, and go down here. We can just open my little test file, which is... Oh, I'm probably covering the microphone. So here's my little test file. It's basically just a cityscape. We can open that, and then we wait. And while we're waiting, you can... I mean, I don't know if you can hear it, but I can certainly hear my fans, like my CPU fan and such, spinning up. Because there's so much just processing involved in doing this. So this takes... I thought it took several minutes, but it takes several seconds to get to this point, to get all the processing done. So we're going to wait. There we go. So you see we have our original cityscape here, and then we have our kind of the result of the red-green processing here. You can see some of the buildings are outlined, and then black-white, we have really distinct outlines here. Yellow-blue, this is actually like showing the inside of the building or something. And then, of course, we have the combined view, which just averages everything together. Alright. So you saw how long that took, and that's the .NET implementation. So, like, all that is running on the CPU, and it is apparently dreadfully slow. I thought about I thought it might be a good comparison to do in C++, but I'm lazy, so I don't want to do that. So down here I have the code to do this in OpenCL, which it's really messy. There's not much error handling and that sort of thing, but it's there. This is the C++ side. It basically just does setup and teardown sort of stuff. Loads the images, puts them in buffers, puts them in memory, and then sends everything over to the OpenCL side of things. Here's the OpenCL side of things. I just basically ported most of my the actual processing code into OpenCL, which, as it turns out, is C essentially. I guess there's a few restrictions on it, but it's at its core, it's C code. And then they added some functions and such, like there's you can see it read image function, and they support vectors and that sort of thing, but it's basically C. So this is my code. I have four different files that are doing various things. 3 that are finding the edges, and 1's that's just combining several images together. And I could probably structure it in a different way. I could do some inheritance sort of stuff, but again, I'm lazy. Up here, I have the output files, which I'm going to delete right now. My elbow to type on the keyboard. There we go. Alright. So we can delete these. Yeah. And, yeah. See, that's the Eiffel Tower. But, let's see. So for this, I just have some command line arguments. This directory, or the path to the file that we're going to be processing, a directory to put our outputs to, and a couple of dimension parameters. And if we run this, it is, well, let's just run it. So I'm going to run without debugging. Here's our screen, and boom. Like, it's just so freaking fast. Like, it's scary fast. And it has all the stuff that we had on that other, other implementation. It does look a little different, and I'm honestly not quite sure why that is. I think most of my sizes are the same, but I could be wrong on that. But we have our composite image of all the different things that have been, all the different sort of layers that have been run, and it accomplished that in like mere milliseconds. And I mean, honestly, most of the I've debugged through this, and most of the time that is actually taken by the program is in compiling the source code for OpenCL. The rest of it is lightning fast. So I'm pretty sure if I basically cache the compiled files, then it would be even faster, and it'd be just like that. I can't snap with my left hand. But, so there you have it. I took something in .NET that was running painfully slow, and I put it into OpenCL, and it ran significantly faster. I was thinking about doing this in C++ too, just for kind of a comparison, just to make sure it wasn't just .NET being slow, but I'm lazy to do that. Bottom line, OpenCL is a really cool way to do concurrent processing, I guess. You can obviously do image processing with it, physics processing, if you want to do that. Anything that you're doing lots of stuff in parallel, basically, which is pretty sweet. And it actually does give you a performance boost, so that's cool. yeah, hopefully this at least helped you find out about some sweet technology that exists. I don't know what else I'm going to be doing with OpenCL in the future. I mean, it'd actually be pretty cool to write a physics engine that runs on OpenCL, but there's already PhysX and all that stuff, so I don't know if there'd be a point to that. But I mean, there's a lot of things you can do with it, and although I'm not sure what else I'm going to do with it besides trying to build out more of the visual system. I encourage you to look into it, and maybe, I mean, there's, if you, at least AMD, if you get their kit for it, that's another kind of issue or annoyance with it, is that every hardware vendor has a different implementation of it, but there's a standard, so you just have to make sure to include the right files and all that stuff when you're building for those platforms. But it's cool stuff, I guess. I had another thing that I was going to say there, but I forgot. But yeah, I encourage you to look into it. Try playing around with it. There's a lot of sample programs floating around that can do like noise generation and that sort of, and filtering, like image filtering and that sort of thing. So encourage you to at least look into that. Might be something cool to just play around with for a while until someone hires you and tells you to write an entire parallel library for them or something. So yeah, that's it.